Ivelin Kalushkov, greetings and welcome to Paragliding Atlas, man. So nice to have you here. How is life?
Good. Not complaining. A bit rainy and not very flyable in Europe at the moment, but otherwise good.
But I love your shirt. Talk to us about Skynomad and all the awesomeness that you guys create, because I remember last time I met your tribe, it was quite an insightful experience, which eventually made me think about it, and that's why I thought it would be worth sharing it to a larger audience. So please tell us, what is Skynomad all about, and how do you make magic in Bulgarian mountains?
Well, we are a very small club positioned in central Bulgaria, but probably one of the oldest clubs in Bulgaria and one of the most active ones. We do everything from training to guiding. We have a big diversity of experience all around the world. Our main instructor, Nikolai Yotov, is traveling all around Africa in the last probably 15 years, developing flying mostly in Africa. Me, myself, I've been to Australia, and I've developed also flying gliders, airplanes, and basically everything. All that experience has helped us to build a fairly successful venue in the middle of nowhere, in the middle of central Bulgaria, but probably one of the best places for flying in Eastern Europe and so forth.
I can totally agree to that, because I remember the nest that you guys have created over there, which is literally basically a house to nest all the pilots that come visit you, which also happens to be home. Was quite a special place to be. So if any of our listeners are more curious about that, just head over to the Kenya episode that we recorded with Nikolai Yotov. Quite a long while, but it was quite an insightful one and has some amazing stories about how he shares the passion with the world and spreads the joy. But one thing about you, Ivo, that stuck out was the way you did the weather forecasting for your group, which was quite insightful for me, because I was out there as a free flyer. And as a free flyer with very little, access to resources, I was just depending upon the weather apps. And the quick fix for any of the pilots I've seen is to just have a glance at the weather apps, have a look at the sky, see if it matches, and then just try to make sense of it. But yours was a very detailed one. So can you please tell us what are the basics of weather reporting? How does one start looking at weather with a bit more finer detail, and then we can dive more into what you guys do. That's going on, man.
Well, our weather forecasting has been really refined over the last probably 15 years. And it has been a very interesting journey because we've seen the changes in basic forecasting in the last, especially probably 5, 10 years. That has made a huge leap from back in the days. Basically, when we started doing what we do and we started doing guiding, we were having also weather briefs for our groups. But literally like 10 years ago, it was actually quite a complex thing with not as much as information as it is available today. And we're still seeing a huge development in the meteorological forecasting overall. About 15 years ago, when we were doing our first group briefings, for example, we had very limited amount of information, as in just a few models that were working. We were going through probably 10 different websites to get different informations, knowing that one website provides good information on one topic, another on another. For example, for Bulgaria, we were having the Greek Institute of Meteorology, and the Greek website was giving very good information on winds, but not very good information on rain. We were having Bulgarian models, which were giving good information on rain, but not very good on winds. We were comparing all that to the NOAA GFS, which was for many years the main meteorological model in the world. So we were basically kind of gathering information from a lot of sources and then doing an on average. Nowadays, a lot of those things have been almost fully automated. There's plenty of information. However, from my experience, I think pilots are also not very interested in getting too deep in that information, or for some of them, it's quite complex to understand. If we talk, for example, QTs, for a lot of people, in my experience, there's still a bit of a mystery, and I think that actually can be quite easy to read if you just follow a few simple rules. So today, I think it would be very easy even for a common pilot to do his own very well detailed forecast just by going to one or two websites, really, getting what he needs. There is plenty of information there. There is sometimes too much information. It could be a bit overwhelming as well. But we also have to realize that we don't need everything that's given to us. We're interested in micrometeorology and mostly localized effects when we're picking a flying spot or forecasting en route for a flight day.
Makes sense. And because it gets overwhelming and there's too much information to process, was the reason why I thought it would be so amazing to have a chat with you, because that 15-minute of briefing that you did, which was probably a bit longer than that, if I'm not mistaken, it was just so enriching. So to begin with, let's talk about the few models that Windy shows us. Windy happens to be the foremost application for all the free flight enthusiasts. And while browsing Windy, I could see they have ECM, ECMWF, GFS, Meteor Blue, Icon EU, and UKV. So 5 offerings from the most popular app. What are these 5 offerings all about, and why do we have 5 of them available on an app which is basically showing any one given point of time? Any one at any given point of time.
Well, Windy actually uses just a few of the models that are available for any given place. In reality, for Europe, I think we have, let me just check, I think for almost any place in Europe, we have more than 15 models or about that much, which are actually available. But as I said, not all of them are useful to us. Windy became popular as one of the most reliable websites because it was the first one to introduce the very good visualization of winds, these nice graphics that everyone knows. But for some time, Windy was using mostly, I think, GFS, Icon, and the Meteor Blue model, really emphasizing on the Meteor Blue model. Windy still to this day is bringing new innovation, not only in visualizing the graphics, but also in averaging the models. Currently in the world, I think there are two main websites which are actually combining a lot of models to provide good forecasting, and that's Windy and Meteor Blue. Actually, sorry, three websites. The third one would be SkySight, which is highly specific for flying in general. While Meteor Blue and Windy are kind of general meteorological websites, which are still quite useful to us though. Personally, I don't use Windy so much because I actually would like to see all the other models. I will show you later an example. But I personally prefer Meteor Blue. Not to get sidetracked, the reason why models exist is because they serve different purposes most of the times. A lot of the models that you will see and a lot of the models people talk about have been created either by different agencies, different meteorological agencies around the world to serve the purpose of forecasting locally. For example, we can have models that are focused on agriculture, which are really good at forecasting quantities of rain, but are not so interested about local wind flows. We can have models which are very focused on winds, direction, and strength, which are usually aeronautical models, and so on. So different models have different purposes. We have global models such as the ICON and the GFS. We have European models which serve the purpose of forecasting only in Europe. And basically all of these have different ways of calculating the weather, different ways of calculating and interpreting the data they're getting from live sources. So each one of them will output a slightly different reading of the data it already has. So that's the main reason why we see these different models in all the different websites. And to this day, they will still read things a little bit differently, and they'll be more reliable in one direction or another, or in one specific parameter or another. There is no universal model, but there are models which do averaging between other ones. There are combining models as well, such as the NIMS, for example.
All right. So basically, just to sum it up for our listeners, models are run by countries or agencies which have their own data collection points all across the globe, or whichever area they are sourcing. And then they collect data from those points, and then they run their algorithms or calculations, and then give an output. And there are 3-4 major, you can say, companies doing this, or setups which do this. And that eventually forms Meteor Blue, ECMF, GFS, or Icon EU. Is that correct? Have I understood correct?
Yeah, pretty much. It's basically a combination of smaller models into bigger ones, which are we're more interested in.
Got it. So let's say ECMFs, ECMWF, GFS, Meteor Blue, Icon EU, UKV. What's the difference between them geographically? Are they owned by different companies, or can you just give us a little bit of an introduction about who is running the show behind these and where are they most accurately based from?
So pretty much every model was run by a different agency. For example, GFS, which was one of the most popular ones about 10 years ago, which is now a little bit outdated. I think even support for it has stopped. I'm not entirely sure about that. But the GFS was developed by the National Oceanographic and Aerospace Agency, NOAA, which is US-based. It was a very accurate model back in the days, but it had one problem. It had a resolution of about 22 or 30 kilometers. I think it's 22, which means for any given point, and that's a common parameter for all models, on any given point that the weather is forecasted, the forecast is for a radius around that point of 22 kilometers. And this is one parameter which is really important in forecasting in general. This is the resolution of the model itself. Different models will be characterized by different resolutions. For example, GFS is 22. ECMWF is, I think I have it here, it's 9 kilometers. NIMS can be down to 4 kilometers. And that resolution is very important. If a model forecasts that it's going to rain, let's say, in London, in the center of London, if the model has a 22 kilometer radius and it rains anywhere within 22 kilometer radius, the model says we were right, which is not actually what we need. In paragliding and flying in general, we're interested in more localized effects and more micrometeorological effects. So for us, it's important to know the weather a little bit more precisely. So if it says it's going to rain in the center of London, we want to know that it's going to rain pretty much in the center of London. In that sense, for example, NIMS has 4 kilometer radius. If it rains within the 4 kilometer radius, then the model is correct, which brings precision to a whole new level. This is one of the main differences between different models. The other difference is how they're calculated. All meteorological models require large amounts of calculations. They're calculated on supercomputers, and this is one of the most expensive thing in forecasting. I am not sure about the exact price, but I think the owner of SkySight, which calculates his own model, was mentioning prices of about $40,000 for a fairly small area to be calculated once. I don't know, it was something absurd as amount of money and calculation power. And the way the models are set gives different outputs as well. So for example, GFS, as I said, was the US NOAA model. ECMWF is the European model. I forget the abbreviations, to be honest. But ECMWF is basically focused on micrometeorological forecast in Europe. And NIMS, for example, is the Meteor Blue own model, which kind of averages all other models, and I personally like probably the most. ICON is a global model. I'm not sure by which agency it was run. I think it was based in France. I'm not entirely sure. But it focuses on calculations mostly in Europe and globally on slightly different calculations and different resolutions. For example, ICON can be as small as 2.2 kilometers, or it could go up to 13 kilometers in calculations. And of course, the outputs will be different on the different resolutions of the models.
Makes sense. A quick question comes to my mind that when we look for general weather forecasting, let's say we Google it up, or on any search engine, if we put weather forecast, we get search results from weather.com, AccuWeather, and like BBC is doing their own website and predicting, and every country has their own specific website where the general population logs on to check the weather. So how is weather.com or AccuWeather getting their data? Do they have their own things, or are they just combining all of these calculations and trying to present the best possible outcome to the public?
From my experience, some of those websites or those agencies, they will literally copy whatever they see on one model they prefer, or they will do their own average sometimes. There are some national agencies which will do their own forecasts. Pretty much all around the world, in every country, all meteorological agencies release, still to this day, meteorological balloons and do calculations based on the data of those. So in some places around the world, for example, in Bulgaria, the National Meteorological Agency do their own forecast. I don't think they use a particular model, but it's different for every provider, it's different for every website. I know websites which literally take whatever they see on one model or the outputs of one model, or they just copy the data from another website. It's a little bit different for everyone.
So when it comes to the hardware, as you mentioned, sending balloons out in the atmosphere is quite a popular way of reading data. And then, of course, having set weather stations is also another way to gather data points around this. Which one works for long-term and which one is most accurate for short-term forecasting? Because I think as pilots, we pretty much rely on short-term forecasting. So when we are trying to place our trust in a provider, what kind of, hardware we should look at or try to keep in mind?
So first of all, when you're looking at forecasting, you have to understand one thing. There is no accurate forecast for more than 72 hours a day. It's a general thing in meteorological models. All meteorological models errors grow exponentially with the time you're trying to forecast for. In my experience in aviation, any forecast over 3 days ahead is a wild guess. Like chances are very low that it might or might not happen. So if you do forecasting seriously, you know that 72 hours ahead, the weather is pretty much unpredictable. This can vary. For example, in the more dynamic parts of the year, when we're having and expecting more dynamic weather, such as spring and autumn, we can have forecasting inaccurate after 12 hours or 24 hours. So then the forecasting periods grow smaller. The weather changes more dynamically, so recalculations need to be done more dynamically. And of course, when the weather is more stable, like in midsummer, yes, you might get a fairly accurate forecast after 72 hours, but that is, again, really dependent on the time of the year. When we're looking at models, in some areas, we can see how often the model updates. Obviously, the more often the model recalculates, the more accurate the short-term forecast will be, usually also the long-term forecast. However, everything is connected. If a model recalculates very often, it will likely experience big changes in the long term, especially, not so much in the short term. So it might seem inaccurate to some people, depending on when we look at the data. If you look at the data now and the model recalculates in 3 hours, the long-term forecast might be completely changed. So if you don't update your own knowledge, it will turn out wrong for you. So it's really important to know when the models update and how often.
Fair enough. So let's say when it comes to paying for weather services, of course, endless supply of open source information on internet. but only so much of it can be trusted. And Windy happens to be one of the most popular ones, which promises to give more frequent updates if you pay for it. Does it make sense to pay for it, or are you paying just to support the service?
To be honest, in my experience, the average pilot can manage pretty much without paid services. The only service that I'm pretty much paying is SkySight because they're really focused on aviation, and I found them to have really accurate forecasts in some aspects. Of course, they're not perfect, but probably one of the best. But apart from SkySight, I think everything else can be freely available. If you want, you can manage completely even without paid services if you're really on a budget.
Fair enough. We are talking about SkySight, Windy, and Meteor Blue. Let's dive right into them. SkySight, you've been telling us that they are aviation based. Windy is more or less all wind sports based. At least that's what they advertise, and Meteor Blue is in general. So majorly, if we have to compare these three, pioneering weather forecasting sites for paragliding, what is the difference between them?
So again, as I mentioned earlier, Windy became popular mostly because of the good visualizations, which are quite popular now on other websites. To be honest, I rarely use Windy these days, but I still do use it because one of the biggest benefits of Windy is a very good live weather map at the moment. For example, in Bulgaria, we used to look at the Doppler radars of Sofia Airport to get information about current rain conditions and how they move because they were almost live. They had very good updates. I don't know how, but Windy managed to get access to that data, and currently Windy is displaying live rain data extremely accurately, almost up to the minute, and it's one of the best ways to check current live conditions. It also is very nice because it combines obviously webcams from all around the world. It's just a very nice tool that combines everything you need to forecast and check the current weather condition. Meteor Blue is pretty much my go-to website for most other things. One of the big things that Meteor Blue did back in the days is that it was one of the first websites to start doing its own average of things. Some pilots are not so familiar with Meteor Blue because they went on Windy first. In reality, Windy actually was for a long time presenting data from Meteor Blue just in a nice graphical way. Nowadays, the two companies are actually united. I think last year, I think Windy acquired part of Meteor Blue, or they had a merger basically. So currently, both companies are working together, and they're having very, very good developments in both websites. But pretty much Meteor Blue, the thing it pioneered was the combination of models and averaging of all models. If you go on the Meteor Blue website, you can see pretty much the output of all meteorological models and their own averager, which is essentially the NEMS model that they present. SkySight, on the other hand, was found by a pilot in Australia, a glider pilot, Matthew Scudder, and it basically replaced the short-term high-resolution forecasting that they had in Australia, and it replaced it very successfully. The specific thing on SkySight is that it focuses mostly on aeronautical sports. It was developed for gliding. It very easily transferred to paragliding. And still to this day, it focuses mostly on flying weather. And we're talking about gliding weather, focusing on thermals, convections, and so on. Its popularity came from being extremely accurate. And I've seen it with my own eyes. If the forecast is going to rain at one particular spot, very often the rain would be 1 or 2 kilometers slightly sideways from that spot. It's mind-blowing sometimes how accurate it can be. And it also gained popularity for really good forecasts on convergence lines and waves for gliders. It was one of the main models that supported, I don't know if you've heard of Perlan missions. It's the sailplanes beating height records in South America, I think. Basically, the pilots in the Perlan plane were flying mostly on a screen with the SkySight forecast overlaid, and they were just following the forecast and finding the wave that got them to, I think, almost 40 kilometers altitude or something like that.
That's mind-blowing. So it was instrument flying more than visual.
Yeah. Not just instrument flying, forecast flying.
Help me understand this, Ivo. This question has come to my mind hundreds of times. I mean, okay, we deal with a whole different level of turbulence, and flying hands-free or leaving controls is a big no-no in paragliders, But if you happen to have a chance to scroll on your phone, like you do when you take photos, or send some information to people that want to know about you, is it possible to read weather on the fly during transitions when you're gliding from one place to another? If yes, is it recommended to try and do something like Perlon? I mean, not Perlon, but like doing your own bit and pushing the limits.
Well, it's actually something that it's done quite a lot. I think now a lot of apps allow a current overlay on the weather. For example, in gliding, I fly with mostly XCSOAR. XCSOAR, it's not so popular in paragliding pilots since XCTrack came along. I'm not actually following the development of XC-Track much, but in XC-Store and the latest versions, you can overlay the SkySide forecast directly on the screen. And I think it's the same with CU. That are outputting their CU app now. CU can do the same thing. So you can follow directly for example, the convergence lines, which is extremely helpful, especially in the sailplane. Sometimes you can literally fly the forecast. You see the line of convergence, you go there, and the convergence is there, and the forecast has been accurate enough, or at least you know the area which you should look for. I very often use Windy again when I'm guiding groups or when I'm flying with the sailplane. If it's supposedly possible overdevelopment for the day, I very often check, for example, Windy's live weather map to see how the rain is developing, where it's moving, so I know which way to guide the group, or if it's getting too hot to land. And on the other hand, if it seems too hot, but it's quite fine. So I think there's a lot of apps that you can actually use in flight as well. It's all a matter of setting up your instruments and knowing where to look.
Fair enough, fair enough. While we were talking about all of this, how about we just pick up one site where people are going out and chasing cross country and have a demo weather forecasting and see how that works out for our listeners?
Yep. And I would be happy to have a look at Manila, which is one of my favorite sites to fly, Southern Hemisphere.
I don't blame you, man. Just when I was starting this podcast about a year ago, I had the honor of hosting Godfrey Venice, the person who basically owns Manila. And I kid you not, and to all our listeners who are interested, just scroll down to one of the first episodes. That episode has had still the highest number of plays on the show until today. It's quite a popular one, partly because of the way he explains the storytelling technique, but also because of the amount of awesomeness that one can create in the air in that location, I guess.
Manila is a small paradise down in Australia. I would highly recommend whoever hasn't flown there yet to give it a go. And in general, Australia is a whole different experience of its own. I spent almost 6 years of my life there, 6 winters, teaching and working with Godfrey, which has also helped me quite a lot in developing exactly my forecasting. Australia is also another good example of a country that has its own meteorological services, which are extremely good. They also have very detailed models for Australia. Very well developed weather services in that area. Also, part of the reason why I do my forecast so detailed was also I learned gliding in Australia, and back in my club, which is just close of Manila. It's called Lake Keep It Soaring Club. In there, they're also doing these very detailed forecasts every morning, and I really love that. And I've kind of got inspired to do the same thing for paragliding back in Bulgaria. So let's dive right into it. Like, if we look at the forecast.
Just before you move on, I love your honesty that you got inspired with the knowledge sharing that you learned and you shared it with the wider community. And that is the whole idea of Paragliding Atlas podcast as well, to keep on spreading the knowledge, because that is the best way to do your own bit and then let the universe take care of the rest, I guess.
Yeah, absolutely. We can have a look at the forecast for Manila. Now, one thing to know about forecasting, usually when we do forecasts for a certain place, I would like to get, first of all, forecast information, basically what we are expecting the weather to be, and then kind of compare that to the current conditions. We have to know that in forecasting, there is also one big variable that is impossible to take into account, and that's local knowledge. There are localized effects which some models cannot even detect. They cannot forecast. So local knowledge is extremely important in any of the cases, and I'm going to show an example of that as well at the end of this forecast. So to have a brief look at Manila, I would generally start with general weather forecasting. I really prefer Meteor Blue to begin with to start the forecast. So I will always look at the basic forecast as well. So if we look at Manila for the next couple of days, we are expecting a fairly sunny sky with a few cues, some possible thunderstorms later in the week, and a bit of rain for today, for Wednesday. Now we have to know that currently it's about evening in Manila. It's already 10 o'clock in the evening. So I think this forecast is outdated so far. But we can check out tomorrow, which seems to be a quite good day for flying. So for Thursday, it's showing generally south wind, about 10 to 16 kilometers per hour with a few cues, not much rain. Let's see how much of that will be accurate. I guess we'll see that tomorrow. But let's have a look at the more detailed forecast. Now, when I'm looking at Meteor Blue, this is a very generalized forecast, but even on the first page, there is a parameter which is very important when looking at the forecast. Down here on each of the windows, we have these bullseyes, which represent forecast predictability. So
there we go.
If we look at down here, this is forecast predictability, and it says predictability is very high. Predictability is another very important parameter in forecasting, which basically shows us what is the likelihood of that forecast becoming true. And it basically shows that all the models forecasting this weather are kind of matching in their opinion, which we're going to see in a little bit. If we want to see a more detailed forecast on that, in Meteor Blue, what I use is the forecast multimodal. If we go to the multimodal page, we'll see all the models available for that particular place in the world. Now, it's important to mention that the amount of models will vary. So in Australia, we have 2, 4, 6, 8, 10 models available for that place. If we switch to a place in Europe, as we switch to a random place in Bulgaria, for example, we are going to see that there's a lot more models for that area. This is Europe. Europe is covered by a lot of more meteorological services. So it's a lot of different models, and you can see they can vary quite a lot in their opinions about the weather in a certain place. Going back to Manila, however, we can see all the different parameters that the models are outputting. So we have the global models such as the NIMS, the ARPEGI, the ICON, the GFS. I don't see the Australian services here, but we're going to have a check on that a little bit later. But if we look at the overall multimodal, it says that pretty much all the models are kind of matching for Thursday. Most of them are showing sunny weather with the difference of the GFS. And as we said, the GFS is very generalized and a little bit outdated, and you can see why. It's the only one that is kind of different from the others. And the other one is the IFS, which thinks it might be a little bit more rainy. Overall, however, forecast is for fairly sunny weather, not a lot of rain. Practically, we can dismiss that. This is very insignificant. Each one of the colorful lines would represent what the wind will be according to different models. So forecasting is for mostly south winds, as we can see here. The arrow shows south, and the models are kind of matching the direction. At around 3 o'clock in the morning, the wind speed is quite low. So the winds are varying, which is, of course, natural. And the other good thing about Meteor Blue, which I really like, is that the Meteor Blue does its own average, which is usually the most accurate thing. If you see all the colorful lines here on the screen, you also see the dashed, the dotted white and black line, which is pretty much the average of what all the models are saying. That's a very good way to visually see what we can actually expect. So we have models forecasting winds as strong as 24 kilometers per hour, and that would be the GFS again, because again, we said it's very generalized. And we can see models as forecasting winds as low as 8 kilometers per hour. So that's almost double the difference. In reality, the average of Meteor Blue says around 15 kilometers per hour, which is quite nice, I think. And here's where the multimodal display of Meteor Blue comes really in handy, because you can really dismiss forecasts for models which are really far from the truth. Also, it's a good way to match what you're seeing on the forecast with reality. For example, if you monitor these models for a few days or weeks, you will clearly see that some of them guess the weather quite accurately. And then you can shift your own forecasts to just picking that model, whatever that model says, to make a more accurate decision for yourself. So this is the generalized forecast still. Another very good thing that I like to use on Meteor Blue is the weather maps, which are now as good as Windy. So if we zoom down here, first of all, we're seeing a little bit of a cyclonic movement of the coasts, which here's where local knowledge comes in handy. In my experience, whenever we get this off the coast in Australia, it can really mess up the weather for even months ahead. But in this case, it's bringing south winds, which are usually very good in Manila. Remember, in the south hemisphere, south winds are actually cold winds, and they can produce really nice flying conditions in the area.
Just a second, Ivo. If you zoom out a little bit, I just want to have a look at the major section of southern Australia to see what's basically going on. When we look at this, we see different colors on our map. We see the wind directions with the visualizations going on. So basically, when we look at this airflow, is there a way to understand something just by looking at it? That over here the isobars, which are not really overlaying on the screen right now, but like, what is the first thought that comes to your mind when you look at a photo like this?
Again, it really, what you want to take into account is the local knowledge for an area. And as I said, for example, when I see big cyclonic or anticyclonic movements in the oceans near the coast, and knowing that Manila is not that far from the coast, it's about 200 kilometers, I know that this can affect the flying weather in that place for quite some time. And if you remember what we just looked at, this was exactly what it was showing for the next days. This will eventually bring rain and bad weather even to the Manila area. Another thing that we need to keep in mind is Australia is huge. It's much bigger than Europe. So whatever we're seeing on the east coast usually won't affect the west coast. So there's not much of an information to draw from such a big picture. The general meteorology is not so interesting as it is the local meteorology. And the local meteorology is currently affected by this big movement here right off the coast of Sydney.
Let me just ask you out of curiosity, what exactly is happening at coast of Sydney right now, and what is causing the winds to move in a circular direction in various ways, and they're eventually, parting ways close to that eye of the storm kind of a thing? Do you have an idea about that?
It's actually quite an interesting thing. Here's where windy is actually better as a display. We can see actually two pressure systems, fairly high pressure systems just off the east coast of Tasmania, and a very small localized low pressure system just off the coast of Newcastle, which is being fed by the high pressure. So in the southern hemisphere, as we know, cyclones and anticyclones have opposite rotation. So we have an anticyclone rotating counterclockwise and the air flowing along the isobars. And we have like a miniature cyclone kind of happening just off the coast of Newcastle, where the wind flows reverses into the low pressure system here. Of course, we also have stacking of the isobars, which will increase the winds in that particular area. But knowing how the air masses move, as soon as they hit the inland, they will slow down and those air masses will decrease in speed. But what we're seeing here is that this area of high pressure is bringing lots of moist and damp air, which will be eventually dumped on the east coast of Australia. Here's where it's important to also look at live data. And again, windy can come really in handy at that. If we look at the weather radar, we should be seeing rain right off the coast, exactly on the low pressure system. We have fairly heavy rain just north of Sydney, not too heavy, but fairly significant, about 40 decibels reflectivity, which means fairly dense rain in that area. Here's where local services are also important. If we go to satellite picture, it will show us the actual rain and look at the rain radar in Newcastle. Yeah, we can see the significant rain that's happening right off the coast and moving toward the coast. And that's live data, which again, windy displays really nicely in a much nicer animation and much more details. And this is almost live data. This is accurate up to the minute.
The color combination here, which is like, dark yellow and red and blue, what does that denote, if you can quickly tell us?
So basically, when you measure the rain content of clouds, you measure it by the amount of radar signal that's being reflected by the water inside the clouds. The higher the reflectivity of the signal, the higher moisture content you're getting there, the more water there is. So down here, if you look at the color map, it says dBz, decibels reflected, basically. I think we can change that to, there we go. We can also change that to millimeters per hour, or how much liters per square meter will be raining. So for example, wherever it's yellow, it's around 12 millimeters of rain per hour. That's 12 liters per hour. And here in the red dot, it's almost 50 to 100. It's quite a lot. If we actually, it should give us more data. That's 48.6 millimeters per hour. That's 48 liters of rain per square meter, which is quite a lot. It's fairly significant rain. The rest is fairly good. It's almost nothing. It's 0.7 millimeters. Not a big deal.
A thought comes to my mind, Ivo, if we are flying at some place and we see one of these, lower radars or like lower color radars being displayed on the screen of windy, is any of this color safe to test or push the limits with respect to going flying, or is any of this color, if it exists, a strict no for taking your wing out in the air?
Well, it really depends on the overall conditions. For example, if we are expecting, according to forecast, thunderstorms, then anything over green shows a fairly good development of the cloud. If it's faint blue like this, I could even dismiss it. This very often could be just a drizzle and not necessarily bad or dangerous. But if it goes to green, yellow, or especially red, it means the cloud has grown really heavy and it's probably already dangerous. Now, again, that depends entirely on what the conditions are. We could be having stratus clouds, stratonimbus clouds, which aren't necessarily dangerous for us. They won't create significant gust fronts or significant suction. It would just mean rain to us. That's all. So it really depends on what kind of conditions you're flying. If it's a general warm front coming through, this not necessarily would mean any danger. It would mean just bad weather. But if it's a cold front coming through like this one, this could potentially mean possible overdevelopment and possible thunderstorms. But with anything over green, you would expect rain, and anything associated with any possible gust fronts, possible increase in the wind, getting wet, and everything like that.
Fair enough. I just out of curiosity, I wanted to ask, in case somebody out there is thinking the same thoughts as me, that how much, because the accuracy is different, and a lot of them can't forecast something else. So, but yeah, thanks for the clarification. Let's move on.
So if we go back to the forecast, if we go back to Meteor Blue, basically, there's a few things which are interesting for us when we're doing forecast. One thing is, of course, wind direction and wind strength. So if we look at Manila, currently the pointer is exactly on Manila. We want to be looking at Mount Bora, which is the actual flying site. And of course, when we do forecasting, we're interested in mostly two things: what the sky will look like. Well, call it three things: what the sky will look like, what the air will be like, and what the wind will be doing. And whenever we're forecasting, we also want to know what the conditions will be in or out, depending on the wind. So wind is pretty much the basic thing. We want to start with that to know if it's even flyable. On Meteor Blue, I personally prefer the general wind map because it has a nice layout of the colors, and it shows you more clearly where the wind starts from. So where the wind picks up or where it slows down. Currently, we're on Wednesday. It's important to be looking for the day we're wanting to forecast. So this is the forecast for 8 o'clock at Mount Bora tomorrow, Thursday. And just in general, if we see the general area, pretty much we want to zoom out to the overall area we'll be flying in. At 8 o'clock, it will be pretty much no winds, only 1-2 kilometers per hour. However, this is based on the ICON model. Now, in my experience, ICON model is not perfectly accurate for winds. I prefer to use the NEMS model, which is the Meteor Blue generalized wind model, which calculates all the present models and does its own average. So for winds, I would like to switch to NEMS in general. Now, here is where we immediately see a difference in the forecasting. Because the wind is light, different models will interpret the data a little bit differently. So if we look at NEMS, it's showing that it's going to be southeasterly winds. If we switch back to ICON, it's showing totally the opposite. It's showing northwesterly winds, but in general, very light. So considering that the winds on both forecasts are really light, we can expect pretty much light and variable wind. Knowing Manila, I would expect to have a little bit of easterly component, however. As the day goes, I would stick to the NEMS model. As the day goes, we'll be seeing a switch of the winds eventually to southwest and an slight increase in the wind. So at about noon, we're expecting southwesterly winds, perfect for Manila west southwest launch. And as the day goes, those winds will slowly increase, getting up to 12 to 14 kilometers per hour at about 2 o'clock at noon. As the day continues, the trend would be for an even further increase, which is a fairly common thing in Manila Valley when we have southerly winds blowing through. As the day continues, the wind direction will turn more southerly with a slight change to southwesterly, and then eventually turning even northerly further out north. But this is about the close to the 200 kilometer mark. So if you get that far, you play it by ear. But up to the 200 kilometer mark, you can have a fairly good flight according to the winds. And this only happens at 6 o'clock, so quite late in the day. So dominating winds according to NEMS model for tomorrow will be southwesterlies. So we know the wind is good. We know that it won't blow out. It won't get too strong, at least till the late afternoon. So I think for tomorrow, wind-wise, Manila could be a very good place for flying, for a very good cross-country flight to the north. Currently, we are looking at the wind, however, at ground level. It's very important when we're looking at forecasts to not only look at ground level winds, but also the altitudes we'll be expecting to fly at. Now, normally, on a normal day in Manila, you can easily reach 3,000 meters. So I would like to see what the winds will be doing at some average altitude, something like 2,000 meters. Now, in forecasting, you won't see heights measured or stated. You will see what the pressure reading would be for the wind at a certain altitude. So when weather data is collected, meteorological balloons give the data for the wind in relation to the pressure they are currently at. This is also the reason why in forecasting, we're talking about winds at a certain pressure. Usually 800 millibars corresponds to about 2,000 meters, roughly, in standard pressure atmosphere.
What is the way to translate this? Because I always get confused between millibars to meters. What is the accurate way to understand 800? What does 800 mean in meters?
The basic rule of thumb and the way to judge it is to remember that pressure drops with altitude. Consider 1,000 millibars sea level, so 0 meters. And for every 100 meter drop, it's 1,000 meters of altitude. So 1,000 at sea level, 900 is 1,000 meters, 800 is 2,000, 700 is 3,000, and so on. So every 100 millibars of pressure drop, it's about 1,000 meters of altitude.
You just unlocked a lifelong mystery, man. I used to keep on Googling up these things. How much is 700 MB to meters? And it was super hard to get an accurate answer. But thanks. It's
for forecasting, most of the times we need the digits between 900 and 700 anyways. You don't really need to go higher most of the times. So If we look at 800 millibars, that should be about 2,000 meters. We can see that there is a significant change in the winds. Even from early morning, we're having significant southwesterlies. And as the day goes, the wind speed actually drops and turns a little bit more southerly, which is actually a good thing. If we are seeing an increase in the wind at altitude during the day, we can expect that increase will affect even the lower layers. And we can expect also our cross-country flight not to go into the correct direction. Because if you're having significant westerlies, as it is in the morning, if you take off too early, you won't be able to go north. You will be pushed into a weird direction to the northeast, which is usually not very nice terrain to fly at. Much more difficult to retrieve, more forested areas. But of course, I don't think you'll be taking off at 6 o'clock and getting to 2,000. So we're focusing mostly midday. And we're seeing that the upper level winds are kind of matching the direction we want to see. They're pushing us more to the north, still a bit of westerly component, still a bit pushing us more to the east, but not too bad. We can counter that. And I think it is possible to fly pretty much straight north with a slight sideways wind component. At the end of the day, winds are turning even more southerly, which should make it easier to keep a straight line along the Manila, Bingra, Oriada road, which is one of the most classic routes. I think it's also one of my longest flights that I've ever done there. And I personally love this route in general. So again, at higher altitude, the winds look, again, pretty good, mostly pushing us to the north and at fairly normal values. We're not seeing any significant increase in the winds. Winds are staying around 12 to 15 kilometers per hour, which is quite normal, quite good.
A question comes to my mind, Ivo. We talk about a lot about wind gradient and the shear layer between the winds that exists, where two different, wind speeds or directions are matching or intersecting. Can you talk a little bit about that? How does that affect real life conditions, and how does that affect flying in general? And are we seeing any of this at all? I mean, I don't think so, because everything just looks in the same direction here, and it is just gradually increasing as we go up.
So for judging wind at altitude, we need to dive a little bit more deep into the forecast, and we want to be seeing a profile of the wind with altitude, or what's called a windgram. And if I select a windgram for Manila itself,
what is a windgram?
It's basically a cross-section of the wind changes with altitude. And basically, we can see how the wind actually changes with height. It's important to know how to read wind flags to begin with. I think a lot of people are also struggling with wind flags, but it's the standard way wind is noted in meteorology. Wind flags are not difficult to read. Basically, the small dash you see here indicates where the wind comes from. So, for example, this indicates northwesterly winds, and the length of the small dash represents the strength of the wind, however, in knots. One small dash is about 5 knots or 10 kilometers per hour, roughly speaking. If you want more information on that, the way to read wind flags is the small dash represents where the wind comes from, and the size of it represents how many knots the wind is. So one dash is 5 knots. If there's nothing, it's less than 5. A longer one is 10, long and short is 15, and so on. So when we're looking at the videogram...
A rule of thumb for knots to go meters per second?
Times 2. For meters per second is a bit more complex. For kilometers per hour, it's easier. It's multiplied by 2. So 5 knots is 10 kilometers per hour. So when we're looking at this windgram, the small dashes are representing the wind direction. And at the moment, the color is representing the speed. So currently, we are looking for the winds precisely on Manila takeoff. Let's just move it exactly on the takeoff. This is a very good view of how the wind will change throughout the day. Out here on the side, we have, for Manila, it's a very easy way to see how the wind will change with altitude for the whole day. So this is the wind at the precise forecasted point. The color represents the speed. So here we have it in kilometers per hour. So from 8 to about 11 o'clock, according to SkySide, there should be almost no wind. Then from 12 to about 3 o'clock, a slight pickup of the wind, mostly southerly, southwesterly. So it might be better for the south launch instead of the west or southwest. And as the day goes, the wind slowly increases, but all the way up to 3,000 meters, it stays southerly. So pretty much south, according to SkySide forecast, with a slow, gradual increase of the wind, and the wind peaking at almost 30 kilometers per hour in the late afternoon. So after 4 o'clock, we're expecting gusts of up to 30 and average speed around 22. So if you want to take off tomorrow, make sure you're in the air before 3 o'clock. Afterwards, it's going to become strong and gusty. With altitude, however, the wind is staying fairly light. Now, when we talk about wind shears, a wind shear will be a layer in the atmosphere higher up where we're having a significantly different wind direction or a significantly different wind speed. Wind shear usually means turbulence for us. And also it could mean that the thermals are interrupted, they're broken, they're more difficult to follow. According to this, however, at least we don't have to worry about wind shear for Manila for tomorrow. So it's looking fairly uniform from ground level all the way up to 3,000 meters. But we're expecting a gradual increase in the wind. So just going back to the Meteor Blue forecast, when we look at the forecast for Manila, we are seeing pretty much also a match between the forecasts of SkySight and Meteor Blue. So we can safely say that the winds will be prevailing southerlies for tomorrow, good for a flight up to the north along the range. The other thing we're interested in forecast would be the general cloud and precipitation situation, basically how the sky would look. So if we look at clouds and precipitation, we'll see again a generalized picture. Now here we're more interested of the overall picture. Now here is where knowing the models becomes important. Personally, again, I don't like the NEMS model for the cloud forecast. I think it's less accurate for cloud forecast, although it is advertised to be more accurate. I think Icon model has a better forecast for cloud and precipitation. So this is what I would like to look for. So I'll be switching to cloud forecast on the Icon model. And according to the Icon model, we are expecting very light cloud cover coming from the east, which is the natural thing again for Manila. And as the day goes, it'll kind of fluctuate. Whenever we're seeing this light shading, we're expecting cloud cover of between 40 to 60%, which very often means very beautiful sky, just hues everywhere. And as the day goes, we're having a more pronounced cloud cover rolling in from the south and eventually probably even covering the area of Manila. So up about 2 o'clock, we're having beautiful possible cues all the way to the north. But as the day goes, later in the afternoon, we might get covered. It seems like it's fluctuating. It's not too bad. It doesn't seem like it will be overcast, but mostly good cues in the first part of the day. And in the later part of the day, this slightly stippled representation, this is quite late in the evening, means that could be serious clouds rolling in. Again, however, Meteor Blue is not the best for cloud forecasting. For that, I would like to resort to the proper websites that are focused on actual aviation weather, such as SkySight. SkySight has a good benefit also of producing a very nice SQT as well, which pretty much can give us all the information we need for a flying site. SQTs, I know, are quite difficult to read for some people, quite a mystery. So let's just have a look at a SQT for Manila.
Thanks for this, Evo. 6 years of flying, and I still get intimidated just by looking at a SQT. So this is another one of the life mysteries that you're going to solve today for me.
Meteor Blue has, SkySight has one of the best representations of a SQT that I can see, that I've seen. And they're also quite easy to read because they've made it into a very nice tool. The SQT can be a very simple thing if you look at it simply. Now, there is a proper way to read SQT when you're reading the wet diabatic collapse rate, the dry adiabatic collapse rate, and all the things that I could use as words, and it will probably make no sense to a lot of people. So I'll just give you the very simplified version of reading a SQT, which I think can do the job for most people. I'm not saying it's the most accurate way to read it, but for me, it's the easiest. Basically, when you look at a SQT, you're looking at how the air changes with altitude, how the temperature of the air changes, how the moisture content changes, and how the dew point, the point at which condensation happens, change. On the SkySight's meteogram, we have the red line representing temperature of the air with altitude all the way up to 11,000 meters. Here on the side, you can also see the meters in relation to the millibars, which we talked about earlier. So here, 850, 700 represent the pressure. But when you move the tool, it shows you also the height at which your current pointer is at. So you have the temperature on the red line, the dew point, the point of condensation on the green line. The blue line is kind of unique for this meteogram. It just shows you the wind as well. It's basically everything in one place. So when we're reading the red line, when we're reading the temperature, we first of all want to see a good tilt. The more tilted this line is, the better the temperature gradient is, which means when a thermal forms, the faster and better the thermal will rise. If the red line is straight up, it means the air is not changing in temperature. It means that there is no temperature difference between the thermal and the surrounding air. If the line is tilted the opposite direction, it means it's inverted. Ideally for us, we don't want to see any inversions and any isothermy, like any stationary temperature without. If we check at the meteogram in the very early morning, we'll probably see some low-level inversions. So let's check 8 o'clock in the morning. And that's a very good example of inversion. You can see the temperature here starts at about 16 degrees at ground level, where I'm positioning the pointer. And somewhere at 800 meters, or if you see here the altitude on the left, at 800 meters, it's barely 13 degrees. Then it rises to 14 degrees. So the temperature of the air is actually rising with altitude. For a thermal to pass through this inversion, the thermal needs to be hotter than 23 degrees, which in the morning cannot happen.
Wait a second. How did the 23 degrees thing came?
Well, it's the tool that SkySight has developed. If you're moving the cursor here, you can actually simulate how hot the thermal can be in order to pass through a certain level. if you're seeing the dashed line, unfortunately, I can't point this. We can see this inversion in the very early morning, which is natural. It happen in the night. In the night, the cold air sinks down to the valley, so we actually have colder air down on the bottom of the valley than it is higher up, and this prevents thermals from going up. This is how an inversion looks like in the temperature graph. So we don't want those. If we have those, it means it's a thermal killer. We cannot go beyond these inversions. If we look at how the graph changes, for example, at 8:30, there is still an inversion. So this means still too early to take off. 9 o'clock, still inversion lingering there. 9:30, it should start disappearing. It starts getting smaller. And I assume by 10 o'clock, it will be very small. So even at 10 o'clock, however, we have a significant inversion over here at about 1,200 meters. Now, this means that it's still flyable below that, but you can't expect climbs to go easily above 1,200 meters. And if we continue throughout the day, already at 11 o'clock, I assume it will be dissipating. Still there, still lingering, however, much higher, climbs up to 1,600. 12 o'clock, it should be gone. 12 o'clock, the inversion is properly gone. So at 12 o'clock, we can see that the bottom line of the graph is pretty straight, and we can expect the thermals to climb over 1,900 meters. Now, how high does the thermal climb depends exactly on the kink of this graph. Even the smallest change in the temperature will usually stop thermals from rising. So for Manila, we want to pretty much look for the middle of the day. The peak of the day will usually be around somewhere between 1 and 2 o'clock. So if we're looking at 2 o'clock, we're seeing that this kink in the graph appears at around this point here. And for us, this says this is going to be 2,500, 2,600 meters. So this is pretty much the climbs we can expect for tomorrow at 2 o'clock in Manila. Roughly 2,600 meters, because below that, the graph looks fairly uniform, fairly straight, without any breakage and inversion. Now, when we're looking at the temperature graph, we want to look also at the dew point graph. The green line here represents at what point condensation will happen. Now, for condensation to happen, the dew point must be within 4 or 3 degrees of the temperature of the surrounding air. So if we look at, for example, this altitude here, 1,400 meters, the difference is huge. We have temperature of the air at 16 degrees, 16.5, and dew point at 9.3. So they're nowhere near each other. Condensation cannot happen. If we go up here, however, they start getting close. So the point at which they're about 4 degrees from each other, we can expect condensation to begin. So the climbs would go up to potentially 2,500, but the clouds will appear at about 2,000 meters, roughly. So somewhere between 2,000 and 2,500, where the temperature difference is about 3-4 degrees, the first wisps will be appearing around 2,000 meters, and the proper condensation will be happening somewhere around 2,200. So cloud base, I would average, would be around 2 to 2,300 meters for Manila at 2 o'clock tomorrow. The other thing we can see on the graph is that the condensation line doesn't stay for very long near the temperature line, which is a good thing. If the two lines are running together for very high altitude, this promotes condensation higher up, which can mean either thunderstorms, because the clouds will go really high, or in general potential rain. On warm fronts, when we have thick cloud cover, these two lines will run almost together for a certain altitude, and this is what's producing rain. If the dew point is moving away, it means the atmosphere is getting drier again, and the clouds won't overdevelop. So for tomorrow, I would say actually pretty good cues at about 2,300 meters. With a fairly good gradient after 12 o'clock. So the best climbs would be after 12 o'clock. Until then, cloud base will be slowly rising from about 1,600 to 2,400 pretty much. In addition to all those things, we can also see the winds here on this graph. And again, we're seeing the wind flags showing mostly southwest winds for Manila, and the wind speed staying around 10 kilometers per hour all the way up to cloud base, which is really, really nice. Fairly uniform wind all the way up. Perfect for flying straight north. And I guess we can check that tomorrow. Tomorrow during the day, we should already see the flights uploaded to XC Contest and see if we were correct about this. So in this QT, you can pretty much see everything in one go. You can see how high the cloud base is there going to be clouds or not? If the green graph never comes within 4 degrees, it will be just a blue day, and roughly how high the climbs will go. It's a good thing when forecasting to also repeat this along the route you're expecting. So if I'm doing a forecast, for example, for a cross-country flight, I'll also move the cursor a little bit more north, and it's about, I think, 50 kilometers, and I will see if there's any change. And it doesn't seem like much of a change. If anything, it gets better. Cloud base gets even higher, at about 2,600. So the further north you go, the better it looks. But the wind at altitude changes to a bit more westerly. If I repeat this even further out, let's go to the 140 kilometer mark, which is, I think, Pingra. Pingra was 100. Situation looks pretty much the same. a little bit less clouds. You see the graphs are a little bit further apart, but cloud base is getting higher. So basically, you can repeat this forecast along the route and have a good idea what weather conditions you're flying in. No matter
what does the spikes like on the green line, which is suddenly going to the left and coming back, which is forming a conical shape? What does that denote? How does that happen?
This is usually a layer of very dry air mass, which could be there for various reasons. It could be just injections of different air masses coming from, let's say, the desert or somewhere else. That just shows very dry air mass, which is actually a good thing. It means that clouds won't overdevelop. This is a limiting factor in the development of clouds. So we cannot expect at this point, at this time, we cannot expect any clouds above roughly this point because the condensation point here is very low. The temperature needs to drop to -20 to start condensing, which is impossible at 3,600 meters. So this is actually a pretty good thing. In addition to the beautiful display of the SQT, SkySight is very easily oriented in all the other parameters we're interested in. It has very good graphs, such as, for example, the potential flight distance is a very easy average of what you can do on a day in a particular place. And I have to say, SkySight is even more accurate for Australia because it was made by an Australian, made for Australia. So we can see that for tomorrow, the potential flight distance, however, I just need to change the setting here because this is set for glider planes at the moment. Let's change the colors a little bit, change the paraglider. So if we check the potential flight distance,
this looks like a tool we all should be using a bit more often.
Potential flight distance for Manila for tomorrow is somewhere between 150 to 180 kilometers, which I think it's perfectly feasible. 150 kilometers.
Where did you see that?
Depending on the colors. So the colors are representing the potential flight distance in kilometers. Here are the colors. So we're in the pretty much dark green area, which is 150 to 180 kilometers. So I think personally, a very good pilot on a day like this can easily make it up to 200 as well.
So let's say the locations that are in yellow are the ones which are most flyable. So if you take off from any of the locations which are painted in yellow on the map, then you can possibly fly 200 and beyond.
You will be working with better conditions, and you can potentially fly further away. So in that sense, it's a very easy way to see how the weather changes around you. Obviously, going from Manila, we'll be passing through an area around Baraba, which probably will have bad conditions or slightly more tricky conditions due to various reasons. If we go through the other stats here, we can see why. And we can actually have a quick look at that. Another good parameter that I find useful sometimes is cross-country speed. Obviously, the higher cross-country speed you're having, the bigger distance you can make. And you can see again from Manila, cross-country speed is fairly high. You can reach areas of about 42 kilometers per hour average speed. Again, this is assuming you're a fairly decent pilot. There are areas, however, where the speed is almost not calculated. This probably means a stacking of clouds or stronger winds, which will show up in a little bit later. We can also check thermal strength, which is a useful parameter, and you can see how it changes during the day. For example, average thermal strength for tomorrow from 2 o'clock is about 3 meters per second, going around 3. Of course, earlier in the day, it will be weaker. But looking at this stat, we can also see at what point of the day the conditions will start dying off. So if we start going to 5:30, so at 5:30, we can expect already thermals to be quite weak, about 1.5 meters per second. And on SkySight, when you start seeing this dots, this stippling, this indicates broken thermals. The bigger the dots, the more broken the thermals, the harder it is to work in. You can also see height of thermals. Again, we saw that from the SQT. And the expected height of thermals would be, just move to new, around 2,500, and getting higher the further north you go. At around the 100 kilometer mark, it's almost 3,000. Another good thing is the cloud cover on SkySight. I find this super accurate in some cases. So if you see the cloud cover, we can see the types of clouds we're expecting. So blue is cumulus, green is usually thunderstorms, and red is usually cirrus clouds, which means breaking the sun, blocking the sun and making difficult conditions. And we see for tomorrow at 2 o'clock, it's mostly queues all around the area, fairly good cloud cover. And around Daraba, where we're seeing the difficult part, you can see it's a stacking of clouds, so probably shadows, which will slow down the flight in that area. We can also see at what point the clouds will set in. So if we check 10 o'clock, or maybe it's blue, no, it's not. So at 10 o'clock, some shadowy areas and no queues yet. So the queues will start probably around 11 around Manila, and they will slowly develop throughout the day up to what we saw later on. We can also see rain forecasts, which again on SkySight can be quite accurate. I've seen those forecasts being as accurate as a few kilometers apart. And again, just like with Meteor Blue, we can check surface wind direction and so on. One other particular thing which SkySight is very popular about is convergence lines. Convergences are basically points where the winds will be meeting up or will be stacking. Usually convergence lines are used for easier flying, very usable in sailplanes, but usable in paragliders as well. So we can see here that in this area, we can expect a convergence of the winds and probably better flying conditions in the route. So if you're planning your route, you kind of want your route to pass through these areas to make better use of them. So you kind of want to avoid the deep blue areas, but want to pass more through the convergence areas.
I'll be thankful if you can explain the color mapping. Like, what does 0.1 and 0.5 have in difference, and why do we see difference of colors in this convergence line? So I'm not able to understand. How does this work?
So this is basically additional lift in meters per second, which is not thermic lift. When two winds are meeting, they kind of collide, displace each other vertically, and you get additional boost, additional lift. So in the areas where you're getting like up to the red and purples, you can have an additional lift of almost a meter per second without actually having thermal. In some places, in some effects, these convergence lines can be really strong. It could be a couple of meters per second where we're talking about atmospheric waves that can be easily utilized by sailplanes. Unfortunately, paragliders are too slow to find these wind conditions. But very often for us as paragliders, these convergence lines will usually mean stacking of clouds and cloud streets as well, and just additional lifts. If you fly along this line, it would be much easier to find the lift and to stay in the lift. Places where we have the darker colors are actually divergence lines, places where the air moves away from. If you fly in these areas, you'll be experiencing usually strong sink or very broken, very difficult thermals as well.
Fair enough.
SkySight in general has a lot of parameters that we can go through. Some of them could be very useful. Some of them are just a good additional information. It also is very good that it saves time for looking, for example, about the average wind I mentioned. For example, if I see the average wind through the thermal layer, this is what the wind will be on average from ground level to the top of to cloud base for that day. And I think this is a very easy parameter. You don't have to look at wind grams. You don't have to look at anything. You just click on it and you see that you'll be expecting around 12 kilometers per hour of wind pretty much on and out through your whole flight, mostly with the same direction. So it saves us all that complex reading that we did on the windgram actually. What we must say, however, according to this forecast, if I can sum it up, basically we're expecting southwesterly winds, cloud base around 2,500 for Manila, conditions kicking off properly after 10 o'clock, and a potential flight distance of about 200 kilometers for Manila. What is important to say, however, no matter what the forecasts are saying, no matter what you're seeing, there is one thing that forecasts are not good at, and that's taking into account local knowledge. I have experience in Manila, I know the area, and I can guarantee you that I just want to have a look at one of the parameters to see if by any chance it's not detected. Not very well detected, but there is something taken into account. I know Manila is a place, I know the area, and for example, I know that in these exact conditions, there is a local effect that appears that it's not calculated in any of the forecasts. So if we look at Manila, just clear the map here, something like rain, because we know that there's no rain for that day. If you look at Manila, you see that to the southwest of Manila, there's a big lake. It's Lake Keep It. And we know that if the wind is coming from the lake, as it is forecasted for the day after, at about noon, somewhere at about 1 o'clock, the lake spills a lot of cold air in this area, and it actually kills thermals. So for those that fly Manila regularly, they call it the Keep It Blue Hole. And they know that the lake actually affects the area of the valley in front of Manila takeoff. And you should be in the air quite early as soon as the thermals are starting, because later on, after 1 o'clock, thermals become very broken from the cold air being poured down from the lake. And that's a very, very good example of a very localized meteorological event that none of the models can predict accurately. So if you just rely on the models, if you just rely on the forecast, it seems like an amazing flying day in Manila. But if you're 1 hour late, you will get to experience the thing that forecasts still cannot do for you, and that's the local knowledge. And this is why usually all the local pilots will tell you, make sure you're in the air before the Keep It Blue Hole sets in.
Interesting. I think, okay, a question comes to my mind. Let's say you're exploring a site by yourself, a site which is not run by any tour guides, a site which is not famous, and people don't fly paragliders there, and tools and sites are your only way to go ahead with predictions. What is the way to navigate the question mark around local knowledge?
Apply your own knowledge as much as possible. Try to look at the terrain, try to take into account all the terrain features around you, all the information you can get from forecasts, of course, but basically looking around you and imagining how the wind flows, where it goes, what can change the atmosphere around you is the most helpful tool. but that builds with experience. And even very experienced pilots can have difficulty in guessing some of the events in some areas. For example, again, I can give a very good example with our main flying site in Bulgaria, in Sopot. Sopot is positioned on the south side of a mountain, and it provides the best flying in northerly winds. And it's something that a lot of even very experienced pilots don't take into account. They will look at the forecast, it will say northerly winds, and they will say, okay, not flyable. But Sopot has a very strong adiabatic winds during the daytime that can suppress very well the northerly wind and actually provide for very good flying conditions. So even your general knowledge about the weather and general knowledge about how the wind flows won't suggest to you that this site can be flyable in this forecast. So even if you're very experienced into judging how the wind flows, or what to expect as turbulence and as valley flows, you can be surprised. So the best thing is to also research areas before you go to them. If local knowledge is there, always try to use it. If not, at least my mantra is always take it cautiously, because you never know what you'll be surprised by.
I mean, the reason why I asked this question is, of course, there's a level of uncertainty when you're exploring a terrain which is completely virgin to paragliders. But when it comes to competing and racing in PWCAs and everything, do local pilots have an edge, or can the visiting pilots nullify that edge by experience is one thing, but by keeping whatever you mentioned, having those things work in their favor and eventually, equalize the playing field?
Not definitely. I think local knowledge of a site and the meteorology of a site can play a huge effect. Absolutely. Yes, probably the most experienced pilots will guess out how the meteorological area works very quickly. But I think local pilots definitely have an edge who are very familiar with localized effects. Again, micrometeorology is really difficult to forecast. And if you have flown a site multiple times and you know how an area works, this definitely can give you a big benefit.
Fair enough, Ivo. I think just to sum it up for Manila, we looked at two sites. That was Meteor Blue and Sky site. So if we have to quickly do a run through, what all did we look through in Meteor Blue, and what all parameters did we look at Sky site? And then we can move on to the next phone and wave effects in Europe that happen.
So again, from Meteor Blue, what we're mostly interested in is, I think, the weather maps. We want to be looking at wind and general cloud cover, minding which model we're using for each one of them. So using names I usually use names for wind, and I use icon for cloud cover. I will switch to icon and cloud and precipitation. These are the two main things that I look on Meteor Blue, in addition to the multi-model, which will give me a fairly good idea how much the models are matching for the current day. And on Sky sites, I would use all the parameters I would prefer, but most of the times I would use the SCUT, potential flight distance as a generalization for the day, and then all the specific details that I want to have a look like, such as thermal strength, cloud coverage, convergence lines, and pretty much anything else that you might need, such as rain or cloud base height and so on.
Right, Ivo. So basically, to sum it up, so far we have had a look at the weather models and what goes on behind them and how we can trust one over the other. And then later on, we have had a look at how to navigate a site specifically, and what all ways we can realize the flying potential of that current day. To wrap it up, I'm just wondering if somebody has to increase their knowledge in general about meteorology, because this is a never-ending topic. The biggest of the biggest pilots still have a lot to learn, because it is a topic which has quite a lot to cover. So in general, as a pilot, once you graduate from school and cross the intermediate CDM or a syndrome or progress in your flying, how do you become better at reading weather?
First of all, never stop seeking information about weather. I think that's one of the topics you can never be good at. There's always new information. There's always new things. I've been paragliding since 2005, almost 20 years now, and I am still getting surprised. I still, when I think I'm having the day explained, I'm surprising what the weather can throw at you. Never think that you can know the weather. But the best way is to observe it, to try to make your own forecast, see how they match with the actual conditions, try to explain to yourself things that are complex, and basically search any meteorological information that you can find. There's really good books, really a lot of tutorials out there to read complex meteorological events. Expand your horizon. Don't just search general meteorological books. It's a lot of information on coming from sailplanes, for example, sailplane pilots. A lot of interesting events that use meteorological events, such as as I mentioned earlier, the Paragliding mission that explored really unique events such as wave flying and so on. but be hungry for knowledge. Look at the weather, do your forecasts, try to match them, and so on.
Is there a mantra which you use to become such a good weather guru at reading everything, or is it just relentless pursuit of knowledge?
Just again, don't be satisfied with what you know. Search for more knowledge.
That's one of the most humble answers that I've received from a guest, Ivo. But I think on that note, we have hit the nail on the head as planned today. So I think one thing all of my listeners will be wondering is if they want your awesomeness in real life, how can they make it happen and where can they reach out to you?
They can always contact us with the Skynomad website. If they're visiting Sopot, they're more than welcome to visit our briefings. We are open to any visitors, not just to the people going guiding with us. I'm always happy to see a lot of people on our weather briefings in the morning. It's our way of giving back to the community and making sure that everyone's safe and having a good fun.
I think I can vouch for that and back it up because I've been a part of that experience, and that is what eventually led me to making sure that we can spread it to a larger audience. So if you ever happen to get to Bulgaria, people, you know where to go. Skynomad is the place to be because that is where they make your flying better. But I think on that note, Ivo, heartfelt thanks from all of us here at Paragliding Atlas, man. It's been an absolute pleasure, and I think no one single podcast episode can cover meteorology and the vastness of it. So we'll be sure to bring you back for topics in time to come. And until then, stay awesome and keep spreading the magic as you do.
Thank you for the opportunity and for all the kind words. I'll be more than happy to expand on the knowledge if needed.